Thanks for joining me today. My name is Arnaud Dazin, and I'm here to talk about why the world needs a decentralized map. Okay, so a bit about myself before we get started. So my background is in games. I've spent almost 10 years working in games at big companies like Namco Bandai and Stormate, where my games were downloaded over 1 billion times on mobile across iOS and Android. And almost 2 years ago, I started a company called AdVR. And AdVR focuses on content and analytics for virtual reality and augmented reality. I want to share a project that we've been working on and developing called the Mapping Aggregation Platform, MAP for short. Essentially, MAP is a decentralized mapping protocol that allows anybody to access information about the world around them. And it allows for devices to crowdsource depth information about the world around us into a map that everybody can use and embed information onto. It provides for a highly accurate, highly updated map built on the blockchain. So as I mentioned, almost 2 years ago, we started a company called AdVR, and placing content in virtual reality turns out to be very easy. Virtual reality has a coordinate system. You have your X, Y, Z, and given a given coordinate, I can put a piece of content exactly where it's supposed to be. But in augmented reality, this changes. Augmented reality doesn't have the accuracy for us to place objects into the space accurately, and that leads to situations like Pokemon standing on the wing of your plane, and it makes it impossible for people to have shared augmented reality experiences because their devices don't have a similar understanding of the world around them. So why is it so hard in augmented reality to do these things? Well, for that, we have to take a look at the existing positioning and mapping technologies that we have. So right now, the typical way that your devices orient themselves in space is using GPS or GLONASS if you're using the European satellites. But essentially, these satellite-based positioning systems are only accurate in ideal situations up to about 5 meters, which is too low accuracy for augmented reality and other devices that need fine understanding of the world around us to position themselves. We also use things like Wi-Fi access points to identify around where we are, but the signal for those devices is also very dependent on the environment around them, and that can lead to a lot of issues. Compasses also exist in our devices, but they're very inaccurate, especially for consumer devices like phones and tablets and things of that nature. As far as mapping technology, mapping has essentially remained the same over the past decade with incremental changes to the process that happens. So essentially, GIS survey companies scan the globe using either satellites, drones, vehicles driving through streets like the Google Street View cars, and those all create a map of the world that is processed, sent to providers like Apple Maps and Google Maps, and then integrated into their systems. But that pipeline takes weeks or months to get new mapping data to end users, and these maps don't have any indoor information, and the accuracy and resolution of these maps is still not high enough for us to understand the world around us, to very specifically understand where we are. Essentially, this is not built for modern advances. If we want self-driving vehicles and autonomous drones and augmented reality to work correctly, we need a map that's not just accurate, but that's up to date, because it being up to date actually ties in directly with its accuracy. So that brings us to how MAP works. So if we look at new consumer devices that are coming out, like the new iPhone, the new Android devices, they all have cameras that can gather some amount of depth information, either using actual depth sensors, like that image in the top right, which is a mock-up of a Google Project Tango device, or if it's computer vision based, like the new iPhone with ARKit. So we look at these apps as they're moving through space, and we capture this depth information and shrink it down to what we call space descriptors, essentially definitions of what the space around the device looks like. So if it's a wall or an edge or a curve on a table. And all of those features are submitted to the map blockchain for consensus, which means that all of the points in one space gathered by a device are compared with all the other pieces of data we gather from devices that have traveled through that space as well. And then once we have a large amount of devices that have submitted information about the space around them, we compare which features appeared across all of the devices. So if 98% of all the devices in one space identify that there's a wall followed by an edge, then that becomes the wireframe layer of this map. Over time, through frequent contributions, this can essentially build up a 3D wireframe of the world that's validated with all the other devices that see the world the same way you do. But that's not enough. If you look at this map, it's very hard to tell what this is. That's because maps, like, without information on them, maps are essentially useless. If I showed you the same map, but with information on it, this map becomes much more useful. And that's part of what's essential to the map platform. The map platform allows for digital information to be embedded directly onto that 3D wireframe of the world. And the map is set up in an open fashion where anybody can read and access the mapping information on it. So what that leads to, with all of those different components, it leads to a map that's always up to date, because consumer devices like phones and drones will travel to places much more frequently than GIS survey drones or Google self-driving cars, because people are everywhere and they go to the places we want to know about. This leads to a map that has sub-meter accuracy, so higher accuracy than any consumer maps in existence today, because these devices now have very accurate depth sensors that allow for us to build out these maps in a way that provides very high resolution, and the devices can localize themselves very precisely and accurately in space. The map platform, built on an open blockchain, is open to all, which means that any information added to the map is immediately shareable with everybody, and the contributions that people make are contributions that benefit everybody who uses the map platform. This leads to interoperable location information, so information that's embedded onto this map is essentially written once, and any other third party can leverage your information. So if Starbucks or a mall or Walgreens have, say, an indoor retail map, that map can immediately be leveraged by other applications that also use the map platform. So what can use this? I've touched a bit on some of these use cases, but essentially the big one is anything that's location-based and requires location for context. So that means augmented reality, anything that involves like pathing as far as navigation and things like that. So for autonomous drones, GPS works well enough, but as soon as they get into dense city environments where there's possible collisions, if you know, in 10 years we have hundreds of drone companies all running drones, GPS accuracy isn't high enough to ensure collision avoidance or making sure that they're following the right paths and their waypoints are accurately planted in 3D space. So it allows for a way for these drones to share information with consumer grade like phones and people on the ground to actually have a shared understanding of the world. And it also allows for online to offline retail engagements like indoor maps and pathing through malls or easy things like that. And there's an interoperability between all of these things. So if you're a mall and maybe you're doing drone deliveries, the drones can immediately and accurately literally pick the products up off of the shelf and take them directly to the person who's using an augmented reality app to see where the delivery is in real time. So all of these pieces can work interchangeably and with each other to lead to a never before seen service environment as far as the world around us is concerned. So why does a map like this need to be decentralized? Well, first off, the data for a map like this needs to be sourced by everyone. People travel spaces much more frequently than anything else, And that's the only way we can ensure that we have enough data to actually have a map that's always up to date. But a big problem with that is there is no gold standard of what the world looks like in a 3D representation. So that validation must actually be done based off of every device around us. We have to actually crowdsource and all agree upon what the digital representation of our world looks like. And that can only reliably be done through consensus. It being on the blockchain means this is open for everybody. And a map like this, historically, mapping information has always been centralized to big giants. So your Googles, your Apples, your Waze, anybody you look at, all of their mapping information is siloed for them to use and to sell as a service, which doesn't help anybody. And it means that the contributions that you're making on Google Maps or on Facebook when they're asking you where you checked in and what you did, that information doesn't actually benefit anybody else without benefiting a large giant first. Making the map platform on a blockchain means that we can open this up to everybody. We can make it available so that everybody's contributions are contributions to the entire community, and the owners of this information are the people who they themselves contribute that information. As far as the token use on a blockchain like this, I wanted to cover the model that we use for it. So essentially, the map of the world is divided up into a grid of tiles. And every tile pays out a fixed reward per consensus period. That reward is paid out based off of consensus validation. So people who submitted points that are validated by everybody else will receive rewards. And based off of how many points they submitted that were accepted by everybody else, their reward is in proportion to that. So somebody who submits, for example, 100 new feature points to the map that are accepted would receive twice the reward as somebody who submitted 50 new feature points to the map that were accepted. Access to the map and the information on it is free. It's really important to us that this information is available to everybody so that everybody can create highly accurate and highly useful location-based services. As far as embedding digital information onto the map, that is also free, but like most networks, map will have inherent limitations based off of the amount of nodes and the size of the network, which means that essentially at some point we will hit a limit of the network capacity. And when that happens, transaction bandwidth for embedding information onto the map is prioritized based off of network ownership. We're building the map platform on the EOS blockchain, and EOS has a resource-based bandwidth system where essentially network owners are guaranteed transaction bandwidth. So if you own 50% of the map, like let's say you're a big mapping giant who submits a lot of information, you own 50% of the map, you are guaranteed the ability to embed 50% of the digital information onto this map. You don't have to spend tokens for it, but your network ownership allows you to embed information. Transactions that you're not using, so let's say it's over the next hour, you know you're not going to use up your entire bandwidth allocation. You can rent that out to other people without losing your tokens, which leads to an interesting model where network ownership is actually incentivized for people to hold and own their tokens as well as continue to contribute mapping data to ensure that they hold the same amount of network ownership and can guarantee their same level of usage on this map. As far as our roadmap goes, so we want to start full-blown development on this in January. So we have some existing prototypes, and we have a patent filed back in late August covering the mapping technology that goes around this. In April, we want to have our initial SDKs out, mostly focused on iOS and then Android. And then we want the testnet for this launched in October. We will be doing a crowd token launch, although I don't want to talk about that. I want to talk about how great Map is. But essentially, part of the funds from that sale will go to licensing GIS map data, which will essentially serve as the initial seed layer for this map that everybody then adds points onto. So that'll get launched in our testnet next October. And that's when we'll start tuning some parameters such as how fast we allow the map to update, how many devices we need for full consensus, and things like that. Then we want the full production network of this map out in March of 2019. And that is how the cookie crumbles. So I see there are questions, so let's start with those. Okay, so first question, how do we handle privacy, or don't we use real pictures as Google Street View? So essentially, I'm a big believer in privacy. I think privacy is really important. One of the big things with this is Map uses no image information for a lot of really important reasons. One, images are gigantic. So if we wanted to store images onto the blockchain, the size of this map would be massive. The other thing, it's very hard to do image-based consensus if we are taking images throughout the day, right? Like an image taken at 10 a.m. in the morning with the sun out versus an image taken at 10 p.m. when the sun is down would make it almost impossible to achieve solid consensus. So essentially, what's submitted to the blockchain is only what we call 3D feature descriptors. So essentially, it's a text-based wireframe of the space around you, which means that there's no real pictures, there's no personally identifying information, there's nothing of that nature. It's a very small, sparse data set of literally a description. So, oh, there's an edge right here. There's a wall right there of 4 meters by 6 meters. There's a curve here. But all of those definitions are essentially descriptors, and they're not images or anything like that. So we chose EOS. So the question is, why did we choose EOS? So we chose EOS for a couple big reasons. First off, so compared to other blockchains like Ethereum, Ethereum requires a gas cost or a transaction cost for every transaction that has to be processed on the network, which doesn't lend itself well to our use case for two big reasons. One, we're going to be doing a crap ton of transactions, and we want this map to be free to read. And the second big angle is if we're embedding digital information onto this map, and like I stated earlier, maps are only really as useful as the information that they contain. That means that now people would have to decide, oh, do I spend a token to save this data point or that data point? And now they've got to decide, is this really worth my token to spend? And we didn't really want to have that as a barrier to entry for people to embed information onto the map. So for us, the per transaction cost on Ethereum was an automatic disqualifier. EOS has several big features that we think are very powerful. So one is they have the entire delegated proof of stake system built into their network. So the whole transaction bandwidth allocation based off of network ownership is built into the EOS model. Their block producer model, which involves a small set of elected block producers, also allows for EOS to do a lot higher transaction bandwidth, which for us is also a very big, important facet of this. So in general, EOS's model was better for our business use case as far as keeping this map open and gathering information onto it. And it's got delegated proof of stake, which is really important for us. So Metro Booming asks, is this all conceptual, or are you able to work on EOS tech now? So EOS is launching officially next year in 2018, but they already have tools on GitHub and some things like that to help developers get started today. So I think EOS's GitHub is the most, if not, or one of the most, if not the most active blockchain project on GitHub. Like they're constantly doing check-ins and working on EOS. It's moving along very fast. As far as we're concerned right now, nothing that we've built is built on the EOS platform yet. So all of our proof of concept code and 3D kind of math that goes into this right now is not built on a decentralized platform like EOS. So we're essentially, our goal is to build this out right now, prove everything out with our centralized version. And then when we launch the SDKs in April for iOS, we want to then start moving it to EOS. And by that time, we should have a lot more tools from the EOS team to make that happen. But even today, there are currently tools on GitHub that you can use to start prototyping what your EOS project would look like. Is it possible that we may move our project to another blockchain? Yes, that is possible. Although right now, just based off of the information that we see. EOS seems to be the most powerful blockchain fit to our use case, but everything is open. So God forbid EOS has launch issues or has any other kind of issues getting to market, then yeah, we'll have to consider using another blockchain. Okay, so Alex asks, what will be the first real-life adoption of the MAP blockchain? So, well, for us, the first big real-life adoption for the MAP blockchain would ideally be augmented reality. So our existing company, AdVR, focuses on embedding content into virtual worlds and augmented reality worlds. So AdVR is an SDK that VR and AR developers install, and that allows them to essentially manage their content for VR and AR, like a content management system. So that would probably be the first real life adoption of the MAP blockchain, is these AR developers who already use the AdVR platform, who would then use MAP to give them a highly accurate, highly up-to-date way of embedding their content into the augmented reality world. That being said, we're focusing very broadly across three big categories. One is augmented reality and augmented reality developers. The other one is autonomous drones and vehicles. And the third one is IoT, as far as sensors that capture data that's location dependent. And so allowing them to embed that data for scientific research and embedding it into third-party apps, allowing them a way to embed that onto a blockchain where they don't need to provide a backend infrastructure to save all their IoT sensor information and share it out. So let's say, like one company, like let's say it's a parking meter, parking spot availability IoT device. Them embedding that onto the MAP blockchain immediately makes that available for anybody else who's making a map that could use that information. Okay, Alex 2X asks, on the AR, are we familiar with SLAM? Yeah, so SLAM, for those who don't know, it's simultaneous localization and mapping. Essentially, SLAM allows for, there's like monocular SLAM, which essentially allows for a camera to triangulate between two frames of a video that they've captured, and then use that to extract some depth information. So yeah, so we're familiar with SLAM, and we do look at SLAM as a way, essentially, SLAM falls into the category of computer vision-based depth identification. And we are looking at integrating some sort of SLAM system into one of our client SDKs, and that would be on the client side. The descriptors that can get sent to the blockchain at the end of the day will all be the same and platform agnostic. Doesn't matter how they're collected. But SLAM is a very useful technology, and especially with, so Facebook has new cameras that are coming out, the X25 and the X18. That are multi-lens cameras that can gather depth information. So we're looking at taking information not just from devices that have depth sensors like Project Tango or hopefully the newer iPhone in like 2018, but SLAM is a really important computer vision advance, and it's getting better every day. But it's anything we can do to get 3D information about the world around us is important, as long as they can capture some kind of depth information and can localize themselves in space, either with GPS or by anchoring onto the existing map layer, we'll accept their depth information. Okay, so Mai asks, this is a great idea. Thanks for sharing. How can we help make this come alive? Well, our team is actively looking for people who want to join our project. So we're hiring across the board as far as engineering goes. So if you're a blockchain engineer, or if you're a mapping engineer, or a mobile developer, or somebody who's really good at 3D math, we'd love to talk. Anybody who wants to help us as far as outreach to actual use cases like autonomous vehicles or AR apps or IoT stuff as well, feel free to contact me later and we can discuss things that can help us. But yeah, we're open, and this is really, we're structuring this as a very big open community project. We want everybody to contribute, so anything helps, right? Okay, so Laura asks, how will the tiles be defined area-wise? Essentially, how the tiles will be defined area-wise is Based off of, so there's a couple systems as far as converting GPS coordinates like latitude, longitude with XYZ coordinates. And we think that's kind of like a very interesting model as far as converting those GPS tile or those lat long tiles into something usable in a typical coordinate system that people are used to for AR and navigation and things like that. Essentially, though, the tiles will be defined by a lat long area. So a lat long tile will essentially be one tile with either like depending on the precision of the decimal of the so essentially like 4 decimals deep or 5 decimals deep into the lat long coordinates, and then each tile will have a predefined width and height, if you will. So the size of those tiles is still being explored. So the tiles are interesting because a map like this has a very large amount of data, even if it's all just descriptors. So we're looking at the tiles provide a very easy way to shard the information, right? So a device in San Francisco, as an example, doesn't need the map data from like Bogota. So these tiles essentially serve as a really useful sharding key. So every tile can be its own small blockchain, or groups of tiles can be their own shard of a blockchain. So we're still, that's something that we'll probably have to figure out during the testnet is how big we want these tiles to be. But right now it's looking like the tiles will probably be essentially an area of roughly 100 meters by 100 meters, depending on where you are on the globe, because latitude and longitude to area vary depending on which part of the Earth's curve you're at. As far as Alex 2X asks, are you thinking how IoT devices will deliver info? Yeah, so IoT devices that don't have depth sensors are essentially just embedding digital information onto the map. And for that, it's a lot simpler. So essentially they can load what we call like a sparse client of the blockchain, because they don't need, like a IoT device doesn't even really need to necessarily, like if they're just say sensors like environmental sensors or parking sensors, they don't need to know anything about the existing map. They just need to write to the map. So essentially they'll have a sparse client that just allows them to do embedding transactions onto the blockchain, as long as they have an internet connection, of course. The way EOS works, by the way, is EOS, for those who aren't familiar, EOS has a decentralized small group of block producers. So essentially there's 21 people at any given time, or 21 nodes at any given time that produce blocks, which means that all of your individual nodes don't have to do the work of creating every block, but they all have the ability to verify it. So these IoT devices can essentially be nodes that are never block producers, that don't necessarily even have to verify. They just submit information to the network, and the block producers handle the actual writing of the blocks with that information. So right now, what stack are we building on? So right now we're building, essentially, we're using a couple different things, but mostly centered on Unity. So Unity is the biggest AR application game engine that people use. So I think it's roughly like 85% of all AR apps are built in Unity. And Unity provides kind of like a standardized way for us to gather depth points. So we're looking at that right now as far as the points. And then on the back end, it's a combination of Python and C++. So we're using a couple different point cloud processing libraries and depth math libraries that allow us to essentially build all this out in a centralized fashion. And one of the big transitions we will have to do is, once we build that all out, actually converting that into something that we can run on the EOS virtual machine. But it's all essentially 3D math, so math can work anywhere, luckily. I've put my email in the chat to make it easy to get in touch with me. Essentially, you can reach out to me anytime. I'm always available and willing to talk. We have a video about Map Platform that's about 5 minutes long that also kind of covers the Map Platform and the uses and what we're trying to achieve.
Whenever a new technology comes along that's revolutionary and that has the capability of changing everything that we do, the transformation is not small, but you can't really see it until you get there. What does a map do to the world? What problems does it solve? Well, it solves quite a number of them that we don't even realize are problems today.
MAP stands for Mapping Aggregation Platform, and it is a decentralized, crowdsourced 3D map of the world. For augmented reality, we're dealing with our ever-changing world. For everyone to see and experience the same embedded content in the real world at the exact same time and place, we need a better mapping system that can provide a higher level of detail of the world around us, but can also update itself as the world changes.
Mapping platforms today doesn't allow for the fine accuracy to provide location-based services and concepts such as augmented reality or autonomous drone waypoints. And historically, all of that information has been centered by large giants that monopolize that information that isn't available to everybody. With MAP, we solve both of those problems, provide a higher resolution 3D map that's up to date and leverageable by anybody, and we also provide a unified layer of information on top of that map that anybody can leverage for their applications.
It's really important that this information is publicly free. This is the Earth. We all own it, and it should be transparent.
Because it's decentralized and built on the blockchain, anyone can submit their mapping information onto the blockchain, and anyone can use that mapping information on the blockchain to build rich and accurate location-based apps and services.
Hundreds of millions of people have these AR devices and these AR cameras in their pockets. Millions of them will have them in their cars and their drones. That, along with a decentralized platform where anybody can contribute and the users themselves can achieve consensus as to what the world around us looks like, has only been possible today. As users are using these depth-enabled cameras through their space, we capture important depth points that identify features in the space around them, tagged with both geographic coordinates as well as approximate orientation of the device. All of that data is submitted to the blockchain.
A blockchain is a block of data chained together with another block of data, again and again and again, creating a chain that goes on indefinitely. If any change in the previous block is done, it will then show up in the next block's hash. This makes all of the data from the past permanent. In the map platform, new data coming in can replace old data that's already existing. So you get what's really a living history of the entire world, and people are rewarded for creating this record of the world.
This allows for us to take hundreds of different perspectives, align them, and then achieve consensus on which are the common points between all of them. And that allows us to slowly build out a sprawling network of feature points in the world around us.
Mapping data on the blockchain has the potential for transforming the human experience of the world around us.
The ability to encode digital information into the real world is something that would affect almost every industry.
MAP is for anybody who's developing a location-based service. So if that's augmented reality developers, drones, or autonomous kind of systems, all of those people can leverage MAP in a way that's free and more powerful to them than any existing system out there. Drones can identify their routes on the map and ensure that no other drone uses their specific route, or weigh the different routes they have and ensure that traffic and congestion issues are solved. IoT devices can directly share their information onto the blockchain and make it immediately available to any application that uses the MAP blockchain for them to incorporate it in whatever way suits their use case. Consumers now actually have an unprecedented say in the creation of this map. Their perspectives are the building block that this platform is built on. The depth data that they capture as they move around allows them to have a more intimate experience with all these apps that they're using. And so that means knowing exactly where there's open parking spots or when your retail store has something you want in stock. So the map platform is for everybody. It allows everybody to understand the world that we have and then represent it in a digital fashion that we can build apps on top of.
Location-based games and entertainment that are social can benefit from the map platform because these applications will be built on an up-to-date map of the world so that we can all experience and see the exact same things at the exact same time. Location-based games and applications can finally be what they were supposed to be, bringing people together, sharing a moment together in real time.
Everybody gains from using this platform. And as developers add more information about their maps and users contribute more information about the world around them, this really leads to a tide that raises all ships. This is unprecedented in the history of the world.
It is a societal technology, and it's a socially transformative one. What it adds to the world is a greater definition of truth.
20 years from now, I hope to one day visit my neighborhood that I grew up in with my children, and not only do they get my perspective of what it was like to grow up there, we can all learn about the neighborhood through thousands of different people. I can ask the earth what happened here at any point in time, and it will be able to tell me. I think it's magical that Earth finally has a way to speak to us.
Well, thanks everybody for taking the time to learn about the MAP platform. And my email's in the chat if anybody wants to speak further. Thank you.